In this video, I'd be talking about threads in Java. The thread class in Java contains 4 constructors as shown here. Every code that you write in Java is executed as part of a thread. So for instance, the main method that you would write is executed as part of the main thread. So when you launch your application, a main thread is created, and the main method that you write is pushed onto the call stack of the main thread. So you would find your main method at the bottom of the main thread's call stack. Let's take a look at a tentative definition of the thread class. So there is an interface runnable which declares a method run, and the class thread implements runnable, and it contains a name which represents the name of the thread. A thread could be named implicitly or explicitly by the programmer. Implicitly, it's given a default name. Every thread has a unique name if it is implicitly assigned. Right, and you could also pass in an instance of type runnable. So this is a constructor where it's given a default name, and you assign an instance of type runnable to job, and this is a method that you need to override because it's declared in the runnable interface. And there is a start method which creates a new stack for a thread and calls a run method. So if job is null, then it calls the run method, else it calls the run method on the job instance. And what should be noticed here is that you could only call a start method on a thread only once. If you call it again, a runtime exception is thrown, and that's probably the definition for handling that. So the first time this is false and count is incremented. Now the next time if you call start again, it throws an exception. And you have methods to set name and get name. Also, a thread is given a unique ID. So similar to that, you would have a get ID method in the thread class. Now, okay, so how do we create threads? It could be created in 2 ways. Uh, well, technically, a thread is called a worker, and the code it executes is called a job. So I could sort of combine the worker and job in one single class by saying class my worker extends thread, and then you override the run method and you define your job in here. So my worker, being a child of thread, is a worker which does the job provided in the run method. So the way you create a thread is by saying my worker is new my worker, and worker.start, right? So this is not considered to be a good object-oriented practice, because the reason why you would extend a class generally is to add more functionality to it, to give the parent class a specific functionality. But if all that you're doing is overriding run method, and if that's the only reason why you're extending a thread class, it's not considered to be a good object-oriented practice. If in case you're extending the thread class to provide it more functionality, then it would be an apt design. So let's look at a more object-orientedly accepted technique, which is to have your job separate from that of a worker. So you say class my job implements runnable, and then you would define your run method in which you define your job. So that's so any instance of my job would just represent a job, and then you would pass the job object to the thread, and you start the thread. In this case, the job is different from the worker, so they're decoupled. Um, um, right? So let's see what happens when you call, in this case, worker.start. Now, because my worker is extending the thread class, it inherits all the properties and all the methods and all the data members of the thread class. Not all of them, but it depends on the access modifier. Okay, now the thread class, as we have seen before, has a start method. Now you could invoke the start method on the worker object, because worker is a type of thread and these methods are inherited, right? So I could sort of imagine this being, the start method is part of my worker class, and that's the reason why you can invoke it. Now when you say, so when this is invoked, you create a new stack, right? Now this is the first time you're invoking, so the if condition would fail and you would create a new stack. And because job is null, you would just call the run method, right? Now because this method is right here, invoking run would invoke this method but not this one, right? So this is where you would define your job. So what exactly happens is when you say worker.start, it would invoke this method available here, right, and creates a new stack. So I have a new stack now, right? And then because I'm calling run, so the run method would be pushed on the stack. So you could find the run method at the bottom of the stack. Right? Okay, now say if I were to have, this is worker, that's worker thread. Now say if I were to have worker 2 is new my worker, and if I do worker 2.start, then there'll be another thread for me, worker 2, and which would have its own run method. Now what the difference between these two is that for this run method is invoked using worker instance, and this run method is invoked using worker 2 instance. So if you were to refer to any instance members within run method, then they belong to work 2. The instance members referred to in run method belong to worker instance. Now okay, let's take a look at how this one operates. So when you do this, what happens is you're invoking the constructor, you're invoking the thread constructor, which takes a runnable type R, and then in the thread there is job, and then you would do R. So now job is not null. Now when you do t.start, what happens is you're invoking this one. Now since job is not null, the run method is executed on job. Now because job points to points to an instance of my job, it would invoke the run method of my job. So when you do t.start, it invokes this one here, right? Well, something like this is also valid. Now moving on, so you could see in here that JVM, all the threads would be running on JVM, and JVM schedules the threads, and each thread would be given a separate call stack. There could be user threads, daemon threads, and JVM only exits when all the user threads are done with their execution, but it doesn't really care about the daemon threads. So this is what it is. You define your job, and this is the worker class. And another case, right, this is all talked about already. And you cannot invoke start method on a runnable instance, or an instance of type runnable, because the runnable interface has only run method but not the start method. Now if you're within the run method, and if you want to get the instance of the current thread, then you would do thread.current thread, which gets the instance of current thread of execution. Alright, so let's talk about the states a little bit. When you do this, this is set to be in new state. When you do t.start, what happens is it executes thread classes start implementation, which creates new stack, places run on the stack, and waits for the attention of JVM. Now T is set to be alive or runnable. Alright, so when you do start, what happens is, for example, say you have T1, T2 are newly created, so they're in state new, and when you say .start, they would move to runnable pool, right, and then the JVM picks one thread out of the runnable pool, and that's how it works. Okay, so so when you this is set to be the new state, and this is set to be a live state, and this is set to be dead state. So a live state could be the one in which the thread could be either in runnable state, running state, or wait, sleep, or block state. It might be blocked on an IO or an object lock. It might be kept in wait within the run method. It might just be put to sleep by the sleep method. Alright, so you cannot dictate JVM onto as to what thread to pick up next, but you can just influence it by certain methods like these ones here.